Hey everyone, this is lesson 222 from the Integrated Math 3 on describing h and k for each family of functions. Technically, coming into this lesson, on the previous lesson, I kind of already given you or described all the h and k values for the parent functions that we've gone over. So here's a reminder of all those parent functions that we discussed. Quadratic and absolute value have been, we've seen this the most, more so quadratic function you're going to see more of. The rest of these come up at different times as we get into more complicated uses of functions. So definitely things that you need to know are the names of the parent function, the parent equation, which would be all these equations where the h and k values are both equal to 0 and the a value is equal to 1. And then the graphing form equation actually shows you where the a, h, and k values are within the equation. All right, so we're going to be looking at today we're going to be looking at a little bit closer at the h value just for a minute, and then I'm going to try to cut this lesson short because technically we've already covered these, but I will have some practice problems available for you to try to do. So as a reminder, transformations, all the transformations begin with your a value. It will tell you the orientation, is it positive or negative, and then the stretch factor. So is it going to be 1, 2, 3? Is it going to be 1/2, 1/3? So usually it's going to be some fraction or some whole number. And then when we talk about stretch factor, I am looking for it's always going to be that positive number, right? Even if it's a negative orientation. Your h value will tell you your horizontal shift. More specifically, I didn't talk about this last time, but when it's a negative h value, that means it's going to the left. Positive h value is going to the right. And then same with your k values. Negatives go down and positives go up. Together, your h and k will give you your locator point, which for some of these, we refer to them as the vertex. So quadratic, absolute value, those are two where we more commonly use the word vertex. But locator point would be a more general term. So what I wanted to discuss today, or really just in this problem, is why does x minus h, the portion, right? All these graphing forms have an x minus h. Why does that shift to the right and not to the left? So this is a common problem, and I have told you this before. Your h value is always going to be the opposite of what you see. So if you see a minus, then it's going to be plus. If it's plus, it's going to be minus. So why is that the case, right? Because most of you probably want to just see a negative here, and you want to assume that that's a shift maybe to the left, when in reality, that's a shift to the right. All right, so let's look at an example where that happens, more specifically with the quadratic function. So here's the parent function, y equals x squared. All right, here's our quadratic. I guess I should have written parent equation. All right, this is a parent equation. Parent function, when I use the term parent function, I'm really talking about the name. Right? Parent equation would be this y equals to x squared. All right, so we know what the default graph should look like, right? It should look like a parabola, and it's always going to be located at the origin. We could plug in numbers, and we could plug in a 1, we'll get a 1. We could plug in a 2, we'll get a 4. Same thing with negatives, negative 1, 1, and negative 2 still gives us a positive 4. So there's some key points that we'll get when we plug in values. Specifically, when we plug in 0, we get 0, right? So that takes us to the origin, right? Most of these functions are always going to have a point that goes through the origin, starts at the origin, or is somehow related to the origin. That's where everything comes from. So when I want to transform this graph and I change it to x minus 3 squared, I'll keep the stretch factor the same. I'm not talking about shifting up or down yet, but if I want to shift it to the left or to the right, I'm going to insert a value inside the parentheses. So whether I write it as x minus 3 or x plus 3, it's going to have an effect on the graph, right? So the question is, what effect does it have? So, and this might answer the question to some of you, like, well, why is it not plus 3, or why is it not negative 3? Why is the h value not negative 3, and why is it plus 3? If you think about this, so here I have the graph of this new equation. So if we actually graph it, right, and we look at its new location, so the vertex has shifted to the right where x equals to 3. So this vertex is now at x equals to 3. So this is where I have the parabola. Now the question is, well, what is the equation going to look like? Well, what can we add to 3 so that it equals to 0? So when I look at this equation, and if I think about, let's say even plugging in a 3, right? If I plug in a 3, and if this was an x plus 3, then that would be 3 plus 3 is what? 6. So that would be 6 squared, which is 36. So when I plug in a 3, I'm not at 36, right? I'm not all the way up here. I'm at actually 0. So the y value is still staying at 0. So what can I plug in here so that this actually ends up equaling to 0? Well, like I said, if I put plus 3, that's not going to give me 0. But if I put a minus 3, then that gives me to 0. So in case you're not following along, this 3 that we're talking about, right? This 3, this is the same 3 we're talking about. So what I want to know is, how do I get that back down to 0? Well, the only option for us is to put a minus 3. All right, so this means, so in order for this to actually work, this equation has to be an x minus 3 squared. All right, but in this case, so when we see this, technically it's like, even though we see this value we always say this value is your h value, you could almost view it as your h value was actually the value of the x that we're plugging in. So this value, right? Let me rewrite this. So this is actually your h equal to 3. So it's kind of it's letting us know, like, okay, well, if this is 3, then that's our h value. What can I plug in to give me 0? That must be minus 3. So this is always going to be a minus. We talked about this is always going to be a minus. So this 3, we're actually looking just looking at this as being our h value. So this is going to be h equal to 3. Now, with all these equations, we talked about all these equations, you'll notice they're all the same. They all have an x minus h. And anytime you see any of these look different, like if it says a plus, that must mean it has to be a negative h value. All right, so if any of these say plus h, must mean that it's a negative h value. So if it's a negative h value, means it's going to the left. And so if I change this equation, if I change this to, let me use a different color. If I change this to y equals to x plus, let's say you use a different number, x plus 4 squared, then as soon as I see this, I should know my h value is going to equal to negative 4, right? Because it has to be the opposite. It has to be the opposite of what we see. Now, if all this was confusing and I just confused you more, then just ignore everything I said. If you feel like you already understood it, then that's fine. I'm just trying to explain this in a different way where maybe last time you were a little confused. But for the most part, like I said before, the simple version of this is when we're looking for our h value, it's always going to be the opposite of what you see. So there's a plus 4, means your h value is negative 4. If there's a minus 3, means your h value is going to be 3. All right, so that only applies to your h value. Your k value is whatever you see is what you get. So if it says plus 5, then that means your k value is 5. If it says minus 6, then that means your k value is minus 6. All right, so I'm not going to go into more examples on h and k, but I am going to go over a few practice problems and on a handout that I will make available to you for you to practice. And they'll go over, I think, 4 of these parent functions. All right, so at this point, we just need to practice. And then as we practice these, it'll get a little bit easier. All right, so here's the handouts that I have available for you. If you're in class, then you should be able to download this and then either hopefully print it out, or if not, you could still work out some of these on paper. There's going to be 18 problems, which I would recommend doing as many as you can until this becomes like super easy and you've practiced a variety of them. All right, so especially if you could print this out, it shouldn't take very long to do this at all. All right, so there's a couple pages. I'll just show you. Here's 9 problems on the first page, and then the second page has another 9 problems. They're all asking for the same information. So I'm going to start going over this. I'm going to do a few problems just to give you an idea of how to do this, and then I'll let you do this on your own. And if you need help, you need question, or you have questions, then reach out to me so that I could help you out. Or if you want me to check your work, if you're struggling on this. All right. So let me just start with, I'll start with problem number 1. So our goal is to be able to look at this equation, to graph it, and then to describe stuff about it. There's a lot to describe. I'm not going to focus on some details like x-intercepts and y-intercepts because I feel like most of you should know that at this point. But I'm going to focus on some simple details. Do you even know what the name of the function is? Can you tell the orientation, stretch factor, and locator point? That's key information here. All right, so just by looking at the equation, what is it that we know? So let me start this. So I see that there's a squared in the equation. So right away that tells me that the parent function is a quadratic. And then if you aren't sure, look at the list that I gave you earlier in these notes, or maybe from the previous notes. Make sure you know the names of your functions. And then orientation, if I want to look at orientation, things that I'm looking for are, and I'll put this on the side. So I need to know what the A value is. I need to know what my H is. I need to know what my K value is. Those are the three things I need to know. In this case, the A value happens to be 1. Right? If you're not sure, the A value is right in front. And since there isn't one, the default's always 1. Our H value, like we just finished talking about, is going to come from our plus 1 that we see here, which means it's going to be -1, right? It's always the opposite. And then our K value is going to come from the end. So this is going to be a -2. All right, that's all the information we need to answer some of the stuff at the bottom. So that A value is a +1. So right away that tells me my orientation is positive, which means it's going to be facing up or upward. I'll put the word upward, but it's a positive orientation. Stretch factor, well, that's our A value as well, which is 1. And locator point, well, the locator point comes from our H and K. So this is going to be, we have a -1 and we have a -2. So that's where our locator point is. That's our vertex. So I would probably start with that information first. And then the last thing would be to actually graph it. Try to graph it without using a graphing calculator. If you're struggling, then by all means go ahead and use a graphing calculator, use Desmos, so that you can get used to graphing it. Once you get an idea of how to graph these, it's a lot faster to do it without the calculator. So I would start with -1, -2. -1, -2 is right here. So that right away I know that's my vertex. So this is my vertex, right? -1, -2. And so I need some extra points. You could plug in numbers if you'd like. I'm kind of already familiar with this graph. If there is no stretch factor, then usually what I'll do is I'll go up 1 over 1 on both sides. And then I'll go up 1 over 1 on both sides. That's what I'm talking about. Or up and to the left, or up and to the left and up and to the right. And then I'll also do it, go over 2 and then 1, 2, 3, 4. Right? 2 squared is 4. 2 squared is 4. So I should have points here and here. All right, so right away this gives me some points. Since there is room, I'll go even further. If I go over 3, this should be, I think there's a point here and here. So the more accurate you can make it, the better for you. Then that means all you have to do is sketch a curve that goes through those points. So let me, all right, so it should look something like this. All right, to me that's easier than having to open up a graphing calculator and type it in. But only because this is a stretch factor of 1. So stretch factor of 1, they're always going to look the same. You could literally copy the same pattern of points. It's when there's a different stretch factor that you might need to use a calculator. So you'll do that for all these. Remember, if it's a negative orientation, it's going to be upside down. And then, for example, if I look at, I'll do number 8. I'll just pick one. So I see this one and I see a cubed, right, exponent of 3, then that tells me the parent function is cubic. And I need to know the A value, H, and K. So in this case, there's a -1 in front. The H value is also -1. And the K value is 0. There is no there is no k value, so it's a 0. All right, and this is your h. All right, h is -1. All right, so now that I know those, that tells me I have a negative orientation because the a value is -1, which means it's going to be facing downward, and stretch factor is still going to be 1. All right, even though a value is -1, the stretch factor is the absolute value of your a value. So this is going to be 1, and then locator point is going to be, don't forget your parentheses, this is going to be -1, 0. All right, so now that information is filled in, you could literally probably do that for every single problem without even graphing it at first, and then go back and graph them after. And then hopefully it gets easier for you to do that. So -1, 0, -1, 0 is at this point right here. Now you have to remember what the cubic graph looks like. If you don't, then look back at your notes where I gave you some pictures. I think in the previous notes, I had pictures of those for you. So this is the one where it has one arm up and one arm down. So definitely what I do know is a couple of points. Those are really the only points that I for sure know. I'd have to plug in numbers. But most likely you would just have to plug in maybe like 2 numbers to actually get a couple extra points. So if I actually plug in the number 1, then that's going to give me 1 plus 1 is 2, 2 cubed is 8. Oops, I have these in the wrong place. So this is going to be, so 1, 2, 3, 4, 5, 6, 7, 8. Oh, wow. I hope I counted right. So this is 1, 2, 3, 4, 5, 6, 7, 8. And that means if I plug in a negative, what is this? -1, -2, -3. If I plug in a -3, that's going to give me also, it's going to give me a +8. All right, so this is going to be, hopefully that's right. So 1, 2, 3, 4, 5, 6, 7, 8. Yeah. All right. So here, if I sketch this, this is going to look something like this, and then something like this. All right. So this should look like one arm up, one arm down. You'll notice it has been flipped. The traditional cubic actually looks like this. So that's what it should look like. But now that it's negative orientation, it would look like this. But you'll notice it's been shifted to the left. So that's why now it looks moved. All right. So the key point here is, this is your locator point. All right. So let's see if you could practice that. And then, let's see, maybe I'll do one more. All right, I'll try this one. So number 14, I'll try to do this one. And this is, hopefully you notice, there's a square root in this. So that instantly should tell us this parent function is square roots. We want to still need to know our a value, our h, and our k. In this case, our a value is 2. Our h value is -4. Right? We're still looking here. This +4 tells us it's going to be at -4. Right? This is -4. And then this -3 at the end is going to tell us our k value. All right. So this tells us our a equals to 2, tells us our orientation is positive, which is still facing upward. Maybe I'll remove that. That might confuse you on the square root. Stretch factor is 2, and then locator point is going to be our -4, -3. All right, so then I'm going to start with -4, -3, which I believe might be here. 1, 2, 3, 4, down 3. All right, so this is our locator point, right? We're always starting with our locator point. So this is locator point. And what I do know is the square root function looks something like this. Remember, it looks like half of a sleeping parabola. So it should look something like this. The only difference here, though, is it actually has a stretch factor of 2. So you might need to plug in some numbers so that this works out nicely. So this one's a little bit tricky. Since I am taking the square root of a number, I probably want to take the square root of a perfect square. So what number should I plug in that when I add 4, it gives me a perfect square? So it would be really nice if I had the square root of 9. So that must mean if I plug in a 5, that might give me a good number. All right, so let's plug in a 5, x equals to 5, that's 1, 2, 3, 4, 5. So I'm looking to see, once I plug in x equals to 5, where's my y value? So 2 times the square root of 9, which is really 2 times 3, which is 6. 6 minus 3, because don't forget there's still minus 3. 6 minus 3 is 3. So when 5, 3 is what I'm looking for. So 5, 3 is a point I'm looking for. All right, so that's one option. Another, we could actually plug in 0 here as well. I didn't think of that one. So if I plug in 0, then that means I'm taking the square root of 4, which is 2 times 2, which is 4 minus 3, right? Because there's still the minus 3. So that gives me 1. So 0, 1, 0, 1 is actually another point, right? So there, now we have enough to sketch this graph. And there you go. Really, I just had to plug in 2 numbers, and that's all that really fits, right? So we could plug in a lot of other numbers, but they're not going to be whole numbers. So you try to choose the right numbers. If you're struggling with that one, definitely use a graphing calculator to help you on that. All right, and then don't forget the absolute value function. You might want to review your notes on absolute value. There's actually a fast way to graph those, which for sure I would not use a graphing calculator for those. So your task is to see if you could go through these easily. If you could go through all these by the time you finish all of these, and it's easy for you, then that is amazing. So that's exactly where you should be at. All right, so look at the handout. Whether you're writing on the PDF that I'm sharing with you in class or printing it out, either way, try to utilize that if you can, or you can at least copy the problems from there. So I'm going to slowly scroll through these in case some of you just want to copy the problems from the video. But for the most part, you should see a combination of some quadratics, some cubics. We saw some square roots, and then hopefully you see that there's absolute value on these as well. All right. Hopefully you don't struggle too much with this. If you do, please reach out and let me know if you have any questions. All right.